Hi, I'm Tutor Frank. Now today we are looking at equations of motion in physics. Equations of motion. Now think about this. Now imagine a young man trying to catch up with a vehicle. Okay? Now three things comes to mind. How fast is he going to move to catch up with the vehicle? How far will he going to travel or journey to catch up with the vehicle? And how long will it take him? So, how far talks of distance, how fast is speed, how long is time. So, equation of motions are simplified formula in physics used for calculating these three: speed, distance, and time. And look at it. The first here is v equals u plus at. V and u are final and initial velocity. A is acceleration, t is time. So, this means velocity and time. And the second is s equals ut plus half at squared. S is distance, u initial velocity, t is time. So this means distance and time. Now, of course, you have your initial velocity given. Now the third is v squared equal to u squared plus 2as. V is final velocity, u is initial velocity, s is distance. Of course, a is acceleration. Alright? So this means speed or velocity and distance without time. So the question you are given will determine the particular equation of motion to use. Now, we have a question I'm going to solve very quickly. Now, let's read it together. The driver in a motor car of which the total mass, 800 kilogram, and which is traveling at 20 meters per second, suddenly observes a stationary dog in his path 50 meters ahead. If the car brakes can exert a force of 2,000 Newton, what will most likely happen? Option A here says the car will stop immediately. Option B says the car will stop 30 meters after hitting the dog. Option C says the car will stop 20 meters in front of the dog. Now this is a jam question that has posed a lot of challenge to many students. Now let's solve it together. First thing first, we'll bring out our parameters, okay? Our parameters, what we're given in the question. Now the question says the driver in a motor car of which the total mass is 800 kilogram. So my mass M is what? 800 kilogram. Now, which is traveling at 20 meters per second. That's the initial speed or the velocity now. So U is equal to 20 meters per second. That's a symbol for initial speed, okay? Now, in his path 50 meters ahead, observe the stationary dog in his path 50 meters ahead. So the distance between the car and the dog is 50 meters. So my S is 50 meters. Now, if the car brakes can exert a force of 2,000 Newton, so my F force is 2,000. What will most likely happen? Now, one thing to state here: when you exert your brake, what happens? The vehicle comes to a halt, a stop. Now, coming to a stop means final velocity V is equal to what? 0. Now, what I'm going to use? Which of the three equations I'm going to use? Now, look at it. In this question, there's no time. There's no time, so I'm not giving time. So that means 1 and 2 is out. So I'm going to use 3 because 3 relates the speed and distance. Okay? And we are looking for distance in this question. Why are we looking for distance? Because we are looking for the distance it will take the vehicle to come to a stop. Because if you match your brake, the vehicle is not automatic. It will travel some little distance before coming to rest finally. So that's what we're going to look for in this question. The distance it will take the vehicle to come to a stop immediately the brake is what? Matched, or the force exerting the brake is applied. So let's go. How do we get the distance? So we're using the top one. So we have V squared equal to U squared plus 2as. Where the V is 0. Now, because it's coming to a stop, another thing I must state is this is retardation and not acceleration. Because the vehicle is coming to a stop from initial velocity to final velocity, which is 0. So coming to a stop means negative acceleration, which is retardation or deceleration. Now what that means is that our A will be negative. So I have 0 equal to U squared minus 2as. So if I collect like terms and move it to the other side, it becomes U squared equals 2as. I want to make S instead of formula distance. So dividing both sides by 2a, I have that S is equal to U squared over 2a, like you can see here. Okay? Now, I already know my U, alright? Now, what is my U? U is 20. So 20 square is what? 400 over 2 times A. But the challenge now is A. I don't know A. But I can get A. How do I get A? Newton's second law of motion. F is equal to ma. Alright? So I divide both sides by m. So my A is equal to F over m. What is my F from the question? 2000. What is my m from the question? 800. This takes care of this takes care of this, so I have 20 over 8. Okay, so my acceleration is equal to 20 over 8. Now let's finish it up now. So if acceleration is equal to 20 over 8, now remember the formula is what? S equal to u squared over 2a, and my u squared is 400, okay, over 2 times a, 20 over 8, okay. Now 2 here 1, 2 into 8 gives what? 4. 4 here 1, 4 into 20 gives what? 5. So I have 400 over 5. 5 here 1, 5 into 400 is what? 80. So it means my distance is 80 meters. So what it means is that if the car brakes can exert a force of 2000 Newton, it will still take the vehicle some 80 meters to come to a halt or to stop. Now remember we said the question tells us that it observes a stationary dog in its path 50 meters ahead. So if it will still take it 80 meters before coming to a stop, and the dog is just 50 meters away, what will happen? It means that the car will most likely hit the dog and will stop 30 meters after hitting the dog, because 50 away from 80 is 30. So the correct option to this question is B. The car will stop 30 meters after hitting the dog. Let me know if you have further questions in the comment section. Bye.